Alrighty, welcome. So this episode is brought to you by Map, Filter, Reduce, Lambda, and Recursion. So this is going to be our 2.2 document. With our full-time program, this is the the third week, but it's the second week of Python, so that's why we got the two there. But off we go. So Map, Filter, Reduce, Lambda, and Recursion. Really cool stuff, really useful stuff. Not all necessarily things you'll use every day, and it does take a little bit of brain juice, but not a ton. I don't think the concepts are hard to figure out what's going on here. It's more difficult to get practice for a lot of these things, but once you have practiced these a little bit more, Map is extremely useful. Map, especially with Lambda, these two together, very helpful. Filter and Reduce, and then Recursion's a really, really powerful tool as well, especially for your algorithms and such. And we'll get to generators, iterators, and then we've got some practice towards the end here. So let's go ahead and launch right in. So Lambda functions, it's just another way of writing a function, but there are some advantages to it as well, and it functions. So I shouldn't say functions. Lambda functions operate just a little bit differently than the way that we've previously worked with. They're called anonymous functions because they're not named. And you can really only call them once, right? Because they're not named, unless you save it to a variable, which we'll get to in a little bit. But they're inline functions, right? So they happen in the same line as the code. They don't move around inside the code. They just get used once in line, and they don't have any name. The keyword lambda denotes the no-name function and executes within a single line. Without saving it to a variable, however, it is not able to be used unless passed in either as a parameter or within list comprehension. Right, so you can use it if it's inline something, but it can be tough to use otherwise unless you're saving it to a variable. So you'll see what this means. It's written as lambda, and then you'll have literally you write lambda, and then you'll have the inputs, right? However many variables you want to pass in, and then you'll have a colon, and then you'll write your function after that. So how this works? We're gonna write a classic. A regular function, right? So we're going to pass in x to our function, and then we'll return x plus 2. Okay? So if I wanted to do print add 2, I would pass in 4 here. It would add 2 to that, and we'd end up with 6. Okay? The lambda version, okay, and so what we'll do, an example of calling it without a variable, two ways of doing this. So we could have, without using a variable to pass in data, we'll have print lambda, I had to have two parentheses here, lambda x, and then x plus 2. Right, and then we'll have another parentheses, and this is what we're actually going to pass into our function. And there's be a space there, my apologies. Right, so lambda x, x plus 2, and we're going to pass 4 into this function. It's going to take 4 as x, add x plus 2, and return whatever's down here automatically, and then it will print it out. So in this case, you can see we print out 6. And then, using a variable, right, we could have 4, we could have a num equals 4, and then we're going to print same thing as we had before, lambda x, x plus 2, and then we're going to pass in a num, and that will take that and it'll spit that out. All right, so saving it to a variable, right? We're going to have a variable f test equals lambda x, x plus 2. Let's keep that spaced out just because it looks easier to read for people. And then we're going to print out f test, and we're going to pass in 4. Okay, so this is a common, easy way of passing that in. F test is a function. It's just a very short thing, and that is how we're passing that data in rather than putting it in afterwards. And this obviously is also going to end up being 6. But Brandon, what if I want to pass in multiple things? Well, that's what we'll do next. We're going to have def multiply. We'll have f, okay, and then we're going to have num. Let's have a doc string here just so that we can talk about what this is, so that when you review this later, you're not lost. F expects a lambda function, because you should be reviewing this later. And then num expects a number. Great. We're going to return f, and then we're going to pass in num to it, right? So we're going to have our function. We're going to put num in. Well, neither of these things are defined yet, so we actually have to call multiply. And here we can pass in a lambda function. Lambda x, we'll have x times x. And then we're also going to pass in 4, okay? So this is obviously all one variable here, and this is our other variable. We're passing them both in, not variable, one argument there, and then our other argument. So we'll have the function and the number, and it will end up running the function with that number passed in. This is just, again, just another way of, passing lambda into a function. I skipped a step. I did. We're going to move all this down here. Anyways. Get rid of that. But anyway, so that's how we would do that, to pass lambda into a function. Okay? And obviously it's going to multiply 4 times 4 and return 16. Again, these are just ways of using lambda, moving it around, that kind of a deal. It's pretty neat. Multiple inputs. Okay, we were asking about this, and then you read the wrong line and got all confused. All right, we'll be right. Multiple inputs with no variable. We're going to print lambda x, y, and z, right? And then we're going to do x times y times z. And we're going to pass in 3, 5, and 8. Okay? Easy enough. Get 120. It just multiplies the 3 together. Off to the races. We have multiple inputs with a variable attached, right? It's just a different way of writing this, putting it in a different way. Okay, so we're going to use our variable x test equals lambda, and then we'll have x, y, and z, and then x times y times z. Same function. We're just putting this in a little differently. So now we're going to have x test, and we're going to pass in 3, 5, 8. Why are we mad? Oh, because Brandon did not write out the whole thing. That's why. Alrighty, so there you go, multiple inputs. There you go. That's how you pass lambda into a function. Returning a lambda from a function. This is interesting too. So, first we have a regular defined function. So define multiply, goodness gracious, apply test, and then we'll have num. And then we're going to return num times 4. Neat. Now we're going to do a function within a function. So we're going to define return func. It doesn't take any arguments. Test is going to be a variable we have in here, and we'll set that equal to 4. And then we're going to define another function, multiply, and we're going to take num, return num times 2. And then we can just return multiply for that. F return equals return, no, we're going to call it return func. Doesn't take anything. We can print return func and see what that is. And that will tell us we have a function here. And we can print f return, and then we're going to pass in 4. Okay, so return func is going to, this is a saved number. It's going to run multiply times 2, and then return whatever that is, right? We are going to do this with lambda in a second. It's going to take way less lines. But you can see that in some contexts, you would want to run a function inside another function. This is how you'd access that. But this way, you're defining a function just to do one short little thing. Why not use a lambda to do that one time single little detail, right? Write a lambda in there, and then you don't have to worry about writing nearly as many lines as many different things. So that's what we're going to do. So lambda function returned from a regular function. So now we can have define return lam, and we're going to have b and c passed in. we're going to return lambda x and a. We're going to do x plus a plus b plus c. Okay? It looks a little chaotic, but you can follow the threads here. We're going to write r lam equals, and again, we're going to save this to the function, return lam 4 and 5. And then we're going to print our lam, and this is what actually sends the data to the lambda here. Okay, so these are the things that go into the lambda. This is going to be our x and a right there, and this is our b and c. And then we run this, we end up with 19, as that is what 3 5s and a 4 add up to. And we have if statements within lambdas. So we could have f, we'll have, there's our syntax. So lambda x will be true if condition, else false, right? This is very similar to how we do list comprehensions. So if f condition, and if you need to go back and rewatch that to review that, that's totally fine. Lambda num times 2 if num is greater than 10, else just add 2 to num. Okay, so here's our condition. We're passing num in, right? We're going to multiply it by 2 if that number is greater than 10. Otherwise, we're just going to add 2 to that number, right? And then we can run that function, f condition. I'm going to put in 8, see what that is, right? So that's 10. It's less than 10, so it just adds to it. We'll run it again, but this time we're going to do it with 12. Okay. 12. I get 24. And then we're going to do it again with just the number 10 there. Okay, and all that does is add the 2 because it is not equal to 10. So there you go. That's how we do our if statements. If else. There you go. And off to in class exercise 1. So write an anonymous function that cubes the arguments passed in and assign the anonymous function to a variable f. Right? So this will be similar to stuff we have up here. You're going to write a lambda function that cubes whatever gets passed into it, and you're going to save that to the variable f. Off you go.